Like she crammed hard.
Yeah,
like,
he-
20
he's
days,
coming
and
down.
then she managed to get to like.
So let's go ahead and get started.
Same with my cousin. Same with my mom.
All right. So the radius of a circular wire is doubled. Radius of a circular wire is doubled, and the length is reduced by a third. If the original resistance is R, what is the new resistance? How do I do it?
Use the formula
PL over
Yeah. So resistivity R is going to be rho, which is resistivity. Sorry, resistance is resistivity times length divided by cross-sectional area A. Okay, this is our formula for resistance. Now, does rho change? No, not unless I change my substance, which I haven't. Okay, does L change?
Yes.
Yes, my length is reduced by a third, so I have 1/3 here. Does my area change?
Yes.
Yes, it does. By how much?
2.
You're doubling your radius, so it's times 4.
Ah, okay. Radius, my area. My area is, since it's a circular wire, it's going to be pi r squared. Since we are doubling the r, we end up with a increase of 4 area.
It's 112. 112.
So our new resistance is 1/12 that of the old. Okay? So if you're looking to reduce resistance, you can decrease the length of a component or you can increase the area of a component. That was easy. Anybody have any questions? Lots of good concepts come from this equation. Am I good? Huh? I actually don't think this one is in the formula sheet. So, is it?
Yes, it is.
Oh, good. So, there you go. Ah,
So the lower the gauge, the thicker it is?
the lower the gauge, the thicker it is. Yes.
That's right.
Yeah.
So wait, how do you measure gauge? So
I'm not
gauge
sure.
is 1, is it 1 over 16 millimeters? Because one of the questions says 16 gauge, and I don't know what 16 gauge is. So I guess there was 1
Anyway.
over meters.
Guys, the book has a table of gauges and resistivities.
What?
Yes.
Oh,
I know a guy that had gauges once.
that makes it so
Okay.
much easier.
Let's try the R. 3 resistors are connected to a 15-volt battery. 15 volts. One's in series and has a value of 60 ohms. So here's our 60. Other two have values of 55 and 30 are in parallel. 55. 55 ohms, 30 ohms.
Yeah.
Which resistor uses the greatest power? So,
Smells like rotten milk.
guys, I'm going to talk about this.
I know. Like it smells like it has the stench of rotten
Yeah, it's a rho. And it's resistance. Resistance is resistivity,
milk.
rho,
I did. I love
times L over A. Yes.
Could you solve this one just like conceptually, just looking at the numbers and how they relate to each other?
I guess you could, but
Wouldn't the 60
I don't know.
use the most power?
maybe, maybe not. I have no idea.
It has
Okay.
Do we have to use the
Yeah, we do. All right, so here's what I'm going to do. I'm going to solve for current, okay? Solve for current, and then look at the potential drops across each. So solving for current, let's condense these two down. 1 over 55 plus 1 over 30. What does that come out to be?
19.411
Is the equivalent?
is the equivalent for the parallel. And then-
19 point what?
411.
412.
Oh, yeah, 412.
Okay, then plus 60, so we got 79.412.
9.412.
So let's use V equals IR. V equals I times 79.41.
Your I is
0.19.
1.8.
What?
Yeah.
Why are we finding current? We haven't added the 60 ohm.
1.8 repeating.
Wait, I got.
Wait,
point,
no, no,
I got
no,
one.
no,
We never added the
Point-
60 ohms that are right in front of it.
Point
We
one.
did. 79.
Oh,
It's
okay.
point. Yeah, it's
Loser.
point one
I
eight.
didn't see that. I just saw 19.4 and then multiplying.
Okay, so we know the current coming out of the battery. Now I'm going to use that current to find the potential drop across this 60 ohm resistor. So V, 15 minus VA, let's call this point here VA. equals I, the current we just found,
I have 2 years left.
times resistance of that 60 ohm component.
11.3 repeating.
11.3.
Wait, no, sorry. Wait, that might be wrong.
Is Subs expect bulbs and stuff?
Oh, you want
Expect bulbs and stuff?
you want the
Yeah, what is VA?
it'd be 3.6.
3.6.
Try
Okay.
giving him a lift then.
All right. So now look what we got. We have the potential difference across each component, and we have the resistance across each component. Okay? We don't have the current across each component. We have the current across this guy, but not across these individual ones. So it might be a better idea to shuffle our equation around. P equals I
D squared over
V, right, to V squared over R.
Yep.
Wait.
That's what I was
Whoa,
thinking.
why would you?
Because we have V equals
You don't
IR.
have to worry about current. Oh, I see. Okay.
So all I do is replace I.
The I with the V.
But how does that really help you?
If now you don't have current.
You don't have to use
Yeah.
current.
Now I don't have to solve for
You
these
already have
individual
current.
current.
Oh,
I
okay.
don't
For
have these.
individual current, I got you.
Okay, so let's compute these for each of them. Let's see. Power of the 61 is going to be V squared, which is 15 minus 3.67 squared over 60. Power of the 55 guy is going to be 3.67 squared over 55, and then power of the
How did you solve for that voltage?
which one?
They have
On the website, is it way more
no, I mean the one in the middle, VA. Potential.
This guy?
That-
I know the potential here, and then this potential is 0.
How do you know that potential?
I know at least 15.
Because I found it.
Drop on the 60.
Yeah.
All different kinds of forms.
The power of the 61 is
Like,
2.14.
Yeah.
I don't know where I can find that.
What's that?
What did you solve for VA? I can't see that.
Oh, all I did was condense the whole current
I
down.
can't see the actual number.
Oh, VA was 3.67.
Point
The
two
next one is
four.
0.24.
Yeah.
0.24
And then it would be wait, it would be
squared over 30.
yeah.
Really want to
0.45.
All right, so
I'm gonna get my master's.
in total, we have 2.14, we have 0.24, and we have 0.45. So yes, the 60 ohm resistor uses way more power than the rest. Yeah, just by itself.
I wonder how long the wait time stands for.
Anybody have any questions?
Is it because the voltage is split up between the other two resistors?
Well, the voltage doesn't split up, the current splits up.
I think you trick someone into eating a mushy Oreo.
I don't know. Because yeah, it seems like it would slide apart.
Yeah.
Well, you gotta get stale toothpaste.
Can you
I would hate
refrigerate
that
it?
as a teacher.
Oh yeah.
Yeah, but you
That's very good. They learn about derivatives today. Mr. Pot, we're learning about derivatives today.
Dude, that sounds so nasty though. He got into.
I'm gonna go home and do that.
I don't have any Oreos.
Use my egg.
I'm gonna go home, buy Oreos.
You get crust.
I think I have some.
All right. So,
And you're gonna
like I said,
My brother and his friend are kind of
do it.
ladies and gentlemen, if you want to talk,
This year,
You
bro,
can
I
head
think that's a
outside.
little too far left. Like if you scoot over a little, I can tell you when. Yeah, because I can't see that. I can tell you.
Are we doing magnetism now?
we are. Oh, yeah, there he is, right on the edge of the screen. Okay. So, yes, like I said, if you want to talk, you can head outside.
Hey, Mr. Yarder,
Yes,
have we gotten to the hard part of like ENM2?
we're about to.
Oh, is that
Yarder.
like you struggle?
Hello.
Hello.
Who's the lucky winner?
Joseph.
You win.
I don't want to.
Okay.
What is it?
Counselor. Yes.
Why?
Wait, you don't mind if we turn in our homework during the test, do we?
During this one.
I'll go between 6 and 7.
Are you gonna record the review? You should get your homework back.
Yeah.
Wait, well, does it say if I
should. That way you can study it.
All right.
and
So. Okay. Anybody want to head out? I'm wasting film here. wasting disk space for YouTube, their servers. Okay. So, magnetism.
Magnetism, but there's a huge vertical line. Are you gonna explain it? That's where the
Yeah, that's where the video ends.
What do you, oh.
Yeah,
are you
this thing.
videotaping?
Yeah.
Okay.
Okay, magnetism. What is the underlying cause of magnetism?
Moving charge.
Rocks.
Moving charge. Moving charge. Anytime you have a charge in motion, you're going to have magnetic forces working. Okay? So, caused by
And on the first day,
moving
like them.
charge.
Wait, so lightning has some magnet?
Oh, yeah.
It does?
Yeah.
I feel like I've seen a video where
That's
someone held,
weird,
like a
like, to
compass.
think about. That, like, things are attracted to lightning?
Sure.
Or does it repulse it?
Depends on the polarity.
I'm kind of repulsed by lightning.
Yeah.
Charge, or like magnetism depending on the spin of the
So what would
electron?
happen
Yes.
if you put a polar
That's how ferromagnetism works.
So,
like a,
wait, so
we put like a polar bear in
if
it,
it's
like-
caused by moving charge, can't they like superpull stuff, which makes things move less, but that makes like super magnetic, right?
No, supermagnetism, you cool things to superconducting temperature, and then you pass a current through it. And current is moving charge, and that's a good point. So,